So we're going to talk about limits, and we have a couple of problems here that we got to solve, right? So we see this function here and say, okay, well, the limit as x approaches -3 is what? Like, basically the question is asking, as x approaches -3, what is the y value of the function approaching? And for a problem like this, we could plug this in. We could just plug in the value to see what we get, right? So the limit as x approaches -3 is going to be, well, -3 squared minus 13, right? And, right, so -3 squared is going to give a positive value. So this is basically 9 minus 13, right? Which will be what, -4? Yes. Right. So this is what your limit is going to be equal to. Now, a key pivotal part that I made a mistake on, that I don't want you guys to make a mistake on. Once you plug in the value of the x coordinate, right, drop your notation, right? It's very important. I know a lot of teachers, they like strict and very concise, precise notation. So once you've plugged in your x values, drop your notation. So in this case, I shouldn't have even wrote this in the first place because I've already plugged in my x coordinate, x value. So something to look at. Number 2 says the limit as x approaches 2 of a rational function is 2x plus 2 over 11 minus x cubed. Well, for this again, if we plug in 2, we don't get what we call an indeterminate form, which is 0 over 0, infinity over infinity, which we're going to talk about in a later video. So something like this, we could just plug in and see what happens, right? So I'm not going to write my notation because I'm going to plug in the values. So, and we could just continue with the equal sign until we find our limit, right? So 2 times 2 plus 5 over 11 minus 2 cubed, right? And this simply just equals, well, 2 times 2 is 4, plus 5, so that's 9, over 11 minus, well, 2 cubed is 8, so 11 minus 8 is 3, and so we can see that our limit is going to be 3, because 3 divided into 9 is 3, right? Let's look at another one. The limit as h approaches 0 of 3 over the square root of 3h plus 1 plus 1. So we see this and say, what the hell is going on? Well, if we plug in 0, we still don't have what's called an indeterminate form. So let's see. So the limit is going to be equal to 3, and I'm going to drop my notation because I'm already plugging in 0. All right, square root of 3 times 0 plus 1 plus this 1, which is not under the square root. All right. And so this now becomes 3. Well, 3 times 0 is 0. So the square root of 1 is just 1. So 1 plus 1 is 2. And we could see that our limit is going to be 3/2. Yes? All right. Let's look at another one. The limit as x approaches 2 of this polynomial function here. All right. So, again, we can just plug in a value and see what's really going on. So -2 squared plus 5 times 2 minus 2. Doing the arithmetic, this is going to be -2. So this is a negative on the outside, because remember, this is not with the -2. You plug in 2 in for x. All right. So -4 plus 10 minus 2. All right, so 10, so -4 plus 10 is 6 minus 2, which is 4. So the limit is actually 4. So as x approaches 2, the y value is actually approaching 4. Let's go to the last one. The cubic function. And this is -2. So the limit as x approaches -2 of the function x cubed minus 2x squared plus 4x plus 8. So something, again, we just plug in. So -2 cubed minus 2 times -2 squared plus 4 times -2 plus 8. All right. Cubing or a negative number to an odd part will always give you a negative value. So this is negative 8. All right, this becomes a positive, so negative 2 is going to be minus, right? Because it's going to be negative 2 times 4, all right? Negative 2 times 4, which is negative 8. So I apologize. Let me rewrite this. Negative 8 minus 8, right? 2 times 4 plus a negative, so that's going to be what? Negative 8 plus 8. All right. So this is going to be negative 16, and this is going to be 0 because sorry about that. Negative 16 is going to be 0 because negative 8 plus 8, that's just 0. Negative times negative 16. So this will be negative 16. So limit as x approaches negative 2 will be negative 16.